All right, so then let's just switch to the proposal. So this is the full API set, right, Jeremy?
Yeah.
Let me just find my cursor again. Yeah.
There's rationale and usage. So the key instigating driver of this is that like trying to read data out of a read-only sequence is complicated because you have multiple segments that you have to work with, and it's easy to like write logic to do that, to cross the segments incorrectly. And it's also difficult to write it efficiently and yet still correctly. So, I mean, those two things together are a big driver of what is pushing the need for a reader that can deal with all that hassle for you, and we can kind of share the logic, throughout the unit. So going through, and I have the sample from the blog post introducing the pipelines, and when you see it, you have to like it's not, this isn't a really complicated one, but like you're doing a buffer.slice, zero.position.value, and then slice buffer to get position, one, position.value, and then you have to advance to buffer start, buffer end. It doesn't read quite as well as it going down below to the actual example of using the reader. So you go to the next code segment.
Yep, let me just...
and it's a restaurant, and because this is an async method, it has to move out of it. But the reader would be reader try read to whatever you're looking for. You process the line, and then you pass the position back into advance to on the other side. Not being able to use ref structs directly in asyncs, that's another feature that's in the pipeline for C# is to allow inlining the methods, at least with static and stuff like that. I'm going to call that up a little bit. It is a little bit easier to grok what you're going to do, especially if you want to do more complicated things in here too. So if we see you with the pipeline in the reader, you end up getting the read result, which has a read-only sequence on it. And the read-only sequence, you wrap the reader around it. And we have a whole bunch of functions we'll see that actually are the key these things. There's just the simple, this one is reading to a delimiter, right, which is like read out binary data and parse the basic types is UTF-8 or UTF-16, depending on what the source data is. So like ints either as binary or as text, and so on and so forth. All of our common things that we have parsers for, so date, time, and the rest. You have to think about like position and really how you slice the thing out quite as robustly. You just get the reader dot position. That's the only time you're really playing with it, right? You pass it to get more data to the pipe. The pipe you ask more data once you run out. Right. So
right.
You don't have to do any of the slicing crap yourself.
So do we only have sequence reader then? There's no buffer reader anymore?
So I have a discussion. I call this one explicitly sequence reader because that's one of the issues we have to talk about is, the read-only sequence is a struct. It's not a ref struct.
Mm-hmm.
The reader is a ref struct because getting the span out of memory is actually expensive. And we cache that to get the necessary performance characteristics that we're looking for.
Right.
Which makes that. But you can't really wrap a span inside of a read-only sequence. And due to that, there's some considerations around both the surface area, because some of these things, in order to not allocate, will return a read-only sequence. So like if you don't want it to like throw a span together for you across the segment boundary, you can just get the sequence back and like, look at the individual bytes yourself or put it together yourself or whatever, and that's another issue I call out. So if we were to have this, and we can have a fuller discussion about that, exactly what the shape is. Do we have two readers and then like and an adapter reader, or do we throw them all together and take a perf hit and have some confusion on the API surface?
Right.
Right. So it's really a matter of performance and having methods that make no sense when it comes to a span, right? Because you can't return a sequence out of a span.
Well,
You can return something that means nothing.
yeah, I mean, some of them get difficult, but so maybe I can provide a bit more background. So there are kind of two different things that happened in the past that prompted us to design this type. One was, there was actually a buffer reader in pipelines, and we were planning to ship it in 3.0 in 2.1. But we ran out of time. So we have actually a buffer reader that ships internally in Kestrel. It's an internal type. But every customer that uses pipelines will need one, probably,
Yeah,
to be able
we
to
pointed like
deal with
10
them.
people to our source already.
Yeah. So that's kind of one reason for this feature, and Jeremy explained it. The second one is we added some APIs in 2.1 to parse spans. Either parse them as text or read kind of binary data out of spans. And when we were doing the reviews, people brought up an issue that it would be nice to have something like a reader, because today what you have to do is you kind of use very low-level static APIs, you pass a span, and it will give you like an int, and it will tell you how many characters it consumed. And you need to then advance the span and kind of do, kind of in a loop. And people were saying it would be nice to have a reader where you wrap it around the span and the reader kind of takes care of the index and kind of advancing. And you just say read next int, skip this character or seek to this character and give me a float or something like this.
So the reader basically takes care of slicing
Yeah.
for you, right?
So one of the comments that I added at the end of this PR is that I have to say I kind of hope that we will end up with a single type. And the reason why I thought, or I still think, that it's possible is that majority, basically as Jeremy was explaining, his reader accepts read-only sequence in the constructor. But the first thing it does, it pulls out the first span, and then majority of the methods, they kind of just operate on the span. And if it runs out of data in the span, it says, okay, well, let me go back to the read-only sequence and get the next span. And it keeps, but majority of the methods just basically operate on span. So I was thinking that we can combine the types, and the only difference between those two modes of the reader when it's initialized with a read-only sequence or a span is that when it runs out of data in the span, there's like, am I in this mode? Okay, well, if I'm in the span mode, I'm done. If you want to read more and I don't have data, it's an error. And in the read-only case, it tries to get the next span and then keeps going. And as Jeremy said, there are some APIs that would probably have to change, or it adds a bit of a, it would add a bit of weirdness to the API surface, but I think there's value in having a single type, and if the weirdness is small enough, I think maybe we should accept it.
So, and I agree that like there's, ideally we would have one type, but there is a cost to it for this, and we can talk. I've listed it out in some detail about what you give up in that case. And one of my other concern, one of the things that comes with that is that like the span stuff would be slower and heavier weight. So, and I talk about that as another one of the issues. One of the things that's just by the nature of needing the positions and like being able to roll back is this struct is very large. It's like over 60 bytes, and it takes a while to construct. It has some issues with passing around. I mean, you need to pass it by ref, or you really start getting hit with performance of copying.
Well, that's true for any reader.
Well,
because it has internal indices, you cannot pass it by value.
so
Because then you're gonna lose when you read in a different stack frame. You're gonna lose when the stack frame pops. So you
sure,
have to pass it by
if you
any
care
case.
about the position on the thing that's passing it in.
When do
right?
you
So,
not care about position when you read?
Well, one thing is like peeking stuff and things like that, but in any case, or wrappers and things and the like. So the
Yeah, I think for correctness, you want pretty much anything that takes a reader to be ref reader, right? Because I mean, you don't know whether the caller will care or not care, so you have to.
generally speaking, but like if you're using a lot of cases, one of the ones that I brought out, and I would really like to look at the API surface before we dig into this one in a big way, but using this sort of thing for interop, for example, like the typical way you would be doing, like performance is really important in a lot of those cases. And what you would typically be doing is not having this thing as an argument. You would be constructing the reader, doing a few things on some native buffer or bytes that you had passed into some Windows API or other API, and then being done. And like a common scenario is doing something like reading out like a header struct, for example, that like has the count of the things that you're going to be getting, reiterate through like anywhere from a couple to whatever, and you're done. And in those sorts of time frames, and like the performance between the creating this large thing or creating this other thing that like has basically two spans in it, one for the starting span and one for where you're currently at, is pretty significant.
So what would be, so if maybe I'm not.
So one of my big concerns, usability is one, and I'll let you finish it, but like one of my big concerns is that like that sort of scenario, people would just give up on using the BufferReader if it added too much weight to it, above and beyond the complexity.
Right.
But I can imagine that some people would care about the overhead. I believe there will be some overhead in creation. I'm not sure if I understand why there would be overhead for reading itself.
Like you don't need to check isEnd or stuff like that.
You don't need to. Why don't you?
Because for span you just have indices and that's enough.
So one of
for a read-only sequence you need to check next pointers.
You're reading from a span, so you have to have some logic when you run out of span, and then in one case you just go to the next span. In the other case you error. So like during the reading, it's always it seems to be the same.
Because
so
I mean you're always standing on one span.
So what we have seen.
Yes. But so I think there will be some overhead.
Yeah.
I think it would be good to understand really like in which scenarios there's overhead, because if it's small enough that I buy your argument, there will be some people who will look at the BufferReader and will say too much overhead for me, and then I think we just tell them, well then use UTF-8 parser that try parse and do it manually, because so I'll tell you also like why I'm so into a single string and single BufferReader. Because in the past, when we designed BCL, it was designed such that it composes. Like we have text or stream reader, and everything like all the sources of data from a stream, you can now kind of abstract it as a stream, pass it to the stream reader, and now use stream reader. Because of the ref structs and our focus on like down to the metal performance, I think we are risking complicated BCL too much, like just having so many types, because we are saying like, if we designed it specifically for this data source, then it would be a bit more performant. And if we designed it for this data source, it would be more performant, and this and that. And soon we're gonna have like, 25 different parsers for ints, because there are many different sources of data where the int can be, and like...
I agree that there's risk for that. I mean, although the bifurcation that we have here is really along two lines, and that's like ref struct versus non-ref struct. So like everything can really basically be wrapped inside of a read-only sequence except for span ref structs, right? That's the only thing that you can't like really do safely.
Yeah,
right?
except that's probably a good chunk of your data input, right?
Well, and also not so. Let's pretend for a moment that you can wrap span in a ref struct. I mean, in the read-only sequence.
Mhm.
Let's pretend for a moment. Your argument of now you have a performance loss because actually it's just a single span, but now I treat it as a read-only sequence would still hold. Therefore, I
So-
don't think the issue is that it's refstruct versus not refstruct. You basically are saying it would be cheaper to read the span than to go through
No,
a
I'm
refstruct.
saying that like the expansion of the types, like the reason why we have two is because of the whole ref struct thing.
No, I don't believe so. You said it's performance, not the refstruct is.
That's the reason why we have two. We wouldn't have more because anything else could be put in the other one, right? So, of of any significance, you already have memory and all these other things. I don't think like we need to be making stuff for arbitrary things beyond that. I don't expect like an explosion of things.
No, but maybe I'm
I think
naive,
that's-
but I mean, like, you could imagine, a buffer reader of T, right, that takes a constructor or has a constructor that takes a sequence and one that takes a span, right?
Yeah.
And so then, of course, the reader will be a ref struct because it has to hold on to the span, right? So
The
it
reader
inherits
the reader is already a ref struct. because it
Exactly.
has
So,
to-
like, I would say that's generally a given of any design, right? Now, my understanding is that the sequence may have multiple spans, right? But you basically start with one. So if you take the sequence, you get the span out. That's your current span. If you take the span directly, then that's your current one, and you have basically a null sequence. So once you run out of span, that's the point where you have to decide you either error out or you ask for the
Yeah,
next
yeah.
span, right? And then maybe you have to do some copying in between or whatever. But I think the question is now, if that's the model, then it would have a single type, which
So-
I think would be.
And you see, the additional problem with two types, so you're saying basically, we're not going to have 10. We're going to have two demos because, I thought that's the argument that you made. The problem is that it's viral. So now I have some higher level component that wants
No, there would be-
to, read from,
There would be three.
so there would be three.
the-
So now I have a JSON parser that, wants to
No,
read
no,
from
no.
spans from this and
No,
that. And
there would be an adapter. That was my suggestion. Is that like, if performance really didn't matter, you use BufferReader. If performance matters and it's critical, and you're in that scenario we're talking about, where you're inside of like, I'm creating a reader and I'm being done with it at the end of this data, right?
Right.
Like, or I have this input stream and it's always a pipeline, right?
Right.
You use the specific one, right? That gets you the high performance.
So which one is the generic one, BufferReader?
BufferReader. Yeah.
Who's where is the type?
What do you mean? Where's the type?
Is this type or some other type?
It would have the same. I talk about it down below. It would be basically the thing that's the union of the two. So, like the things that return a read-only sequence wouldn't be in that because it doesn't make any sense.
I'm a little confused as to what you were saying earlier. Were you proposing that we don't need a reader over span because we could just use the parsers directly?
No, I was saying we should have
He said you don't need performance.
a reader that forwards for you, like manages index and everything. Just one. It's universal. It works with everything.
Yeah.
If the performance penalty is too high for you, drop to lower level APIs and do it yourself.
So to give you a characteristic, and one of the, as Asin and I have been like iterating back and forth with changes to this for a couple months now. A lot of what happens in here, like when you're doing binary reading, it's relatively simple, right? There's not a lot of actual like logic that's actually in there as far as number of methods, right, or number of instructions, excuse me. So in a case like that, introducing just the call to go get next segment actually has a very significant impact. And this is, I have this listed out near the bottom, and it goes like, in some cases it goes up to like 80% slower.
But if you have a span, you do it once.
Now,
Correct? Because you don't have more segments. So the first time you try to advance to the new one, it says I cannot advance, and it's an error.
having the call makes the output code slower.
But you still need to do error checking. Even in the span case, you still need to.
No. Having the method call to go get another span.
Yeah.
Oh, just
is what makes it
existence of
slower.
the.
What? Having a method where?
So
DLL?
the logic to like, we have this try read. Again, we haven't looked at the surface area yet, so this is, I really think we should get into that so like we can have a better discussion about this. But like try read for a binary takes a T and it has to be unmanaged, and it just basically blitz into it, right? It uses the Marshall stuff to do it, checks the size. All right, did you do we actually have that many bytes left? Fine, I'll call the Marshall thing and slap it into that, otherwise it returns false. If we don't have enough bytes in the other case, we have to call back to get the next span. Right?
Yes.
Or we go to a slow method, actually. We don't go to the next span. We go to the slow method that aggregates the stuff for you and does that. It does it on the stack or whatever. It's just that call to that other method is the only difference between the two.
Exactly.
And that call to that other method makes it 80% slower.
But when the call actually is called, or
No,
just
never
it
called.
being in the
Just it being in the method.
in the branch.
So
That kind of makes sense, depending on what method you're benchmarking, because just having that call site will start stack spilling your local variables.
So that's what my point is
Sounds like we should talk to Andy.
Well,
No, it's required.
You're
It's
just kind
required
of-
by the x64 calling convention.
Sure.
you're just kind of
Yeah.
trapped by it. So
Yeah.
in some things it doesn't matter much, right? So when we go to parsing, right, when we're calling UTF-8 parser, so much logic is in the UTF-8 parser, this other stuff gets lost in the noise, right? The fact that you have an extra method call to go and fall back to I don't have a contiguous thing, I need to go to the slow path. That's basically what this stuff is all set
That
up.
can be there is a way to resolve that. We can go over that whenever the time's appropriate. But there is a way to resolve that performance difference.
Okay, for which?
It's possible to structure the arguments to your method call such that you can avoid having the compiler stack spill, and that might end up improving the performance that you see.
If that's even the issue. But yeah, we should.
Yeah.
Yeah, we'll take that one offline with you to look at.
Yeah.
So I'm entirely fine with if we're willing to take the usability hit and take the performance hit to roll it into one reader, and I don't think that we're pressed to completely settle on that now. It's very easy to collapse them and just not show anything else and get rid of all those other things. What I would like to do is get the API surface agreed upon, get some harder measurements,
Yes.
and then come back and look at. I mean, I've got some already, but I would like to take that portion of the argument as a separate discussion to say okay, we've implemented them separately.
Yeah.
This is what, and together, this is what the performance differences are. We've had time for people to think about it and give their feedback, right? And this is the API surface, these are the other things that we have to add, et cetera, et cetera.
Yeah.
Because there's a state problem that comes in as well when you have these things unique. If you want to keep your state, and we have to add a new state thing to be able to deal with it.
So I completely agree.
There's those
And
things.
I was pushing for the unification, and under the assumption that it's not 80%. So Ason has done kind of similar things, he didn't have a different branch, and it was that performance, and then we added a branch, and with various optimizations to preserve inlining and whatnot, and usually it was kind of 10-15% overhead, and I think if we can get it to 10%. 10-15% overhead, I think it's worth sacrificing a bit of performance to have a single time. If it's 80, it doesn't make sense.
So it spans
that's-
across it, and I can give out the hard
Yeah.
details on it. Now, the other thing to remember, of course, too, is it's not 10% overdoing it raw. It's 10% on top of the other 10%.
So anyway, let's get to the I would be interested in. I know you sent some emails about measurements, but I was not. For me, it was not easy to see. You didn't check in the performance tests, correct? So I couldn't
not
see
yet.
what the performances are doing. And
Although
whatnot.
the performance tests are in there, actually.
I
I
see.
just switched. I added a separate one that
Yeah.
used the other readers.
So that's one thing. And second, about the what would the OM look like? I think it would be useful to because we exchanged some emails and comments on GitHub, and you said, the OM would be wacky, and you said, what would we do with this? What would we do with this? It would be good for you to actually say, if we had to have a single type, what would you recommend it look like?
Yeah.
What would we do with these?
And I call that out as an issue, as the thing to follow up on. So we definitely should, and you can see some of what would be weird here, and then it would be good to get some of these methods, no matter how, most of them, right, or the majority of them are going to be the same no matter which way we go, right? Just how many implementations do we have? That's what's going to matter. But I think that there's a fair amount of discussion we're going to have around that in of itself. and understanding what's driving this too. So like, you know, there was already, you know, a comment from David before he left about the is next thing. And like, there's some very specific reasons behind those things. And a lot of the stuff, a lot of the surface area is driven by the sequence reader or the read-only sequence characteristics, right? Like if you were going to design a reader around span, you would never do one of some of these things, right? Because it like, why? You know, you can build that yourself. And when it comes to like allocation stuff, you'll see like that's why some of these helper methods are in there, right? And speed and so on and so forth. Like, they
But
really
anyway,
don't make sense.
but you know, going back to this reader, the main scenario for it is to write higher level parsers. So like, you know, we are writing JSON parser on top of this reader, and sometimes I can imagine we would actually not use the reader because it's too slow. But for lots of scenarios where like customers would implement XML, you know, reader on top of it, or whatever protocol they have. One type would let them basically design one parser that parses either a span or read-only sequence or arrays, you know, like many things. I think the value would be.
I think there's value in it too, which is my counter proposal was that we had an adapter that did that basically. So, you know, ideally we'd be able to find some way to like.
But which way would the adapter work? Because adapter now there's a problem with ref structness. If it's an adapter.
Well, we're already ref struct for any of these. The readers are ref. They have to be because like you can't get good performance out of it if you don't catch the local span.
But you cannot store a span in read-only sequence no matter what.
Hmm?
You cannot store a span in read-only sequence.
No, the read-only
So I don't know.
sequence is a factory for the span.
No.
Because it stores in memory.
No, the buffer reader
Yes.
would take either of the two and be basically constructing both of those two items, or there would be some internal jiggery that we'd be doing that you wouldn't be able to access externally, and wouldn't have the sequence related stuff on it, right?
Essentially, the buffer reader is a
Oh,
ref
so it's
struct
not an
regardless.
adapter; it's a wrapper.
Yeah, sorry, I'm.
Okay, okay.
My bad.
But what would people write parsers against?
What-
If you want to support both, you write it against the wrapper.
Yeah, but then we lose all the.
Then you lose.
Yeah, I want to write a fast parser, not the.
But that's what I'm saying. It depends what the cost is, and depends also like how much you care. So like for JSON, we care to the, you know, an extreme. I can imagine somebody wants to parse XML and they don't care that much. I mean, like, you know, we obsess over the performance and it's good for some things, but we are talking about like nanoseconds, you know, here. So you can do million of those.
Yeah, but
in
we
a
use it in
second.
Kestrel, so it's.
Yeah,
Should be-
yeah. Once you're in the guts of Kestrel, sure, like you pin and you know party on pointers.
Well,
But I don't
yeah.
think that's the level of performance that is required by majority of our customers.
Well, I'm hesitant. I think to say majority, particularly, maybe so now, but I think as we continue to have stuff being running in the cloud, I think these things matter a little bit more. But
The advantage of composing is it's not like the two underlying types go away. So if someone wants to write a reading performance thing, they can say, I have a span, I'll go to the sequence span reader. And I have a reading sequence, I'll go to the sequence reader. And those who don't care are okay with taking 10%, I only want to retain one code part.
Yeah.
They can
But
use
you
the
see,
buffer reader.
but you see that's the argument that I was making before. I kind of now the span reader and sequence reader are the types in the middle. They are neither convenient nor really ultimately performant. Because if you care about performance so much that you are not willing to accept this type with the overhead, you better use UTF-8 parser.
The span reader could be performant.
the span
Well,
re-
UTF-8 parser will be more performant.
What is the performance difference, by the way?
the performance difference
Yeah.
between
Between like having this unified type and having two different types.
He says 80% in some scenarios.
Yeah, but like, is it 80% in a micro benchmark? Is it 80% in Kestrel Hello World?
well, it's micro benchmarks for each of these things, right? So there's a composing, depending on how you're using it, right? So like binary reading is much slower, right? That in the micro stuff, and like if you're using that, then I mean, yes, I mean the overhead of your other stuff that's going on the parser is going to measure it differently as well, but like
And it won't affect the Kestrel because it uses read-only sequence, and that's the one
Yeah.
that's slower anyway.
Yeah,
so it's
but
only
if-
scenarios where you want to read span.
I guess I'm wondering if it doesn't, unless we have evidence that it actually shows up like in a profile run
Of what?
of
Like we do a
they-
private run
Kestrel or
of
the
Kestrel.
JSON parser.
But
They don't
Kestrel
read
doesn't Kestrel
really
doesn't use span overload of BufferReader. It uses read-only sequence one, and the slowness isn't span in span reader. Like span reader is faster than BufferReader, but Kestrel is BufferReader.
Do we have a non-micro benchmark perf testbed for the span reader?
No.
Sounds like we should make one.
Does span reader exist today?
Hmm?
Does span reader exist
I
today?
mean,
I
performance is
started
being
writing
compared.
it to like do
Yeah.
the tests.
Because
but,
without actually knowing like how an actual application written on top of this will behave, like what are we actually? Well, what are we discussing then?
we're discussing like the performance of the individual pieces that you compose into a larger thing. I mean,
No,
this
but I
is
think
significant.
so. Additional observation
Just
along
like-
these lines.
Yeah.
If we design the unified type, and we are not happy with performance, we can always add span reader, because the read-only sequence will not get any slower by supporting span.
Yeah.
And that's what these guys are using.
So let's start with unified type, and if we are not happy with it, we add span reader. That's the argument. There's the second issue of the usability in APIs, but I think from performance perspective, supporting span, tell me if you disagree, would not impact the performance of the read-only sequence reader.
Well, then there's just composability at that point, right? You may impact if you don't design at least that way to start with, then like trying to make the buffer reader take a span reader or whatever could be awkward, or to rip one out. So like the idea with this. Sorry, I used the wrong term again. What did it like? Adapter. What did I?
The wrapper.
Wrapper. Sorry. Perils of doing comp sci way before this. So like the problem is that like oh geez, I got track. Sorry, I flashed back to when I was taking comp sci.
Breathe.
The one of the sorry, now I remember exactly where I was going. The thing that I was expecting, right, is that like you could well, one, you have to keep state, right? We have an issue there with a unified thing. That's awkward. And one of the ways that you could also go into like a performance mode is you could rip out the reader that was appropriate, right? If you really cared. Like suppose you're starting to go down some chain and you have something that passes in a reader and it gets passed to you, and you like have a special path for the span stuff because of, like you're doing things that you know really measure,
Yeah.
right? So you're doing a bunch of binary crap or whatever, and you could basically check it, rip out the span reader, and then go to your next helper method, right, that you care about. If we're not careful, doing those sort of things retroactively could be really hard.
Yeah, we
So-
should be careful. And
Yeah, well, that's why I think it's sort of valuable to start with them outside of each other, finish beating this one with full details and more examination and thought about the usability, and fold them in if we decide that like it's not worth it to have to take the overhead of having multiple types.
I have to say, like the idea of having two types, I think I'm with Christo. Like I find that very scary, because basically what ends up happening is if we both introduce at the same time, right, and both have names that are somewhat what you would be looking for, likely. Like basically people will make arbitrary decisions until they actually measure their stuff, right? And so you end up with a world where some APIs take sequence reader, some APIs take span reader, right? And then you just have this composability issue.
But
which, by the way, you can already see today. Like there's like we have stream and we have stream reader or text reader, right? And some stuff that parses text files only exposes a reader, which is not really sucky if the only thing you have is a stream. And you have to instantiate the other guy and rep that. The other way around is also bad, because if you only XP is stream and you already have a reader, well then I don't have an easy way to expose it the other way around, right? And so people already have to deal with this, and like it has caused problems. And this is just two types.
so
right?
here's a dilemma
It's even
with the other one, right?
worse.
Is like allocation matters, right, to Kestrel. Is that a fair statement?
I would think so.
Yep.
So if you want to write a non-allocating reader or non-allocating usage, you have to use the read-only sequence pieces,
Right.
right? So if you have something where you can't use those, like, so if you're going to use it right, as it stands right now, this one on its own,
Right.
the answer here is like, if you want to make sure you never allocate, right, you don't call the things that return a span, right? You recall the things that return a read-only sequence. You decide how you're going to like put those things together if you have to put them together, right? So whether you're getting stuff out of the array pool, whether you're iterating through that yourself and splitting it up in some other way into a small, it doesn't matter, right? You're in control of the allocation, right? So that's something we would have to address, is that we would have to add more complexity to those things to be like have this thing allow you to do allocations.
Well,
Yeah.
I don't
control
I don't
allocations.
fully agree. I think we can design the API such that they don't allocate and don't have this problem. For example,
Well, sure, we can add them, no doubt, but it adds complexity.
maybe, but
Well,
it may not be too bad.
But I think the
and it
question
has
is,
some advantages.
so
For
let's
example,
say-
instead of when you read a string, instead of returning a read-only sequence, you return two positions.
It's not useful
Why not?
because first read-only sequence is two positions.
Yeah,
it's exactly what it is. Second,
Well,
you
that's-
cannot construct a new read-only sequence by using two positions.
I thought we.
No,
There's a slice method, is there not, that takes
There
two
is a s-
positions?
Well, there is a slice method that needs the original read-only sequence.
Well, you pass the original.
Yeah, so-
right?
Oh,
So
so you
how-
have three things. So you have to keep track of the third.
It would be
And you
have to
it
do
would
it
be
anyway.
ridiculously slow, because you would have to go back and you would have to like, you do contain the original one. You have to
Right.
take the original one and re-index into it through. You would have to walk back through it to get you the read-only sequence back out again.
It's especially for JSON reader.
Fine. The point
Like-
I was trying to make is it would be useful to brainstorm like how we solve the allocation problem, and I think there are many different things
I-
that could work.
I love the idea of a single reader, but I also by using this BufferReader class, I found out that without having a sequence on
Fine,
it,
fine.
it's just
I subjected myself to poking holes. You could imagine try methods that give you
Yeah.
this thing depending when. Like there are many
Right.
different things that we should explore before we throw away.
I think the bigger problem is,
idea of
let's say
having a
I'm an
single
author
reader.
of an XML parser, right? So what do you want me to do? Because I have to decide whether I take sequence reader or span reader, right? And I cannot funnel one through the other. So I have to basically do both. Or I can just say, fuck it, I just pick one, right? Which the majority will be, somebody will just pick one.
Or we create
No,
the
no.
third one, and then you take the third one.
That was-
But that,
no.
Okay, but this one is also a problem. Now we have three readers, and
Right.
now we have to like.
Yeah.
it
And,
just-
and I think that's the problem, right? I mean, you can't really build an ecosystem in order that people have to make a choice, and we tell them, do you want to support that data source or that data source? Well, it depends on how I'm being used. Do I know in all cases? Maybe, maybe not, right? And like that's why I think fundamentally it's not like a pay-for-play thing for a parser implementer, because they have to literally write the code twice.
They don't, for the people that don't care, and like we're going down the road of saying that people don't care about the performance, and that worries me. But like, again, can we?
Yeah, but
can we-
but let's say you're right, right? So let's say that's the ecosystem that we create. So they will just pick one where they don't care about perf. Let's say that's sequence reader, right? So if most parsers just take sequence reader, well, what do I do with this span reader then if nobody takes it? So in that case, like I'm like, okay, I'm back to square one, where we effectively have one type, and the other type is not that useful.
I think his point makes more sense if, let's say, I have input sources either span or sequence, and I want to support both. I'm not going to take a sequence reader or a span reader. I'm going to take the composed type buffer reader,
Yeah.
and therefore
The third one.
Yeah.
So
the
we
one
should
that-
three readers in the
Right.
third one.
Well, that's precisely.
But it's what you have to
yeah,
do,
in
though.
terms- In terms
Right.
of single
Like-
responsibility principle, you would have three types because that's how you would compose, and it actually makes sense conceptually.
No, in that case, I would say let's have two.
an
Let's have-
interface.
Let's
and
have
make
one that
everyone
is the
have a
composed
generic
type. Let's call that, let's say, buffer reader, and we have one that is highly optimized, that's span reader. That would make more sense. to
And
me.
that one let's ship later when we discover that actually we have a problem.
Ah, here we go. I like that.
But here, this is what I would expect would happen. Like, we make the compose type. The span stuff is just going to cause undue confusion. Now, again, like, hopefully we can spend the second half of this looking at the API,
Yeah.
and I think it'll help clarify. Because without knowing what these APIs are doing, it's a little abstract to imagine because again, I'm totally on board with like ship less types as a starting point for things. I really would prefer to have one type. I'm just super concerned about the usability thing, both from like the API surface and from a performance thing. So like my fear, let me put it this way, is that like what we would do is we'd give out a buffer reader that people would be super unhappy with from a usability standpoint.
Right.
And then people that wanted to use it for span would never use it because it would just not meet the characteristics. So we'd have this functionality that nobody would use outside of like having to write conditions in their code to say like, oh, well, I can't use the read-only sequence stuff or whatever else, the way it's actually being used. Because right now, what we have is not a buffer reader. And that's why I changed the name of this. What is in Kestrel is a sequence reader. And that was what we were looking at for the last one.
Let's go ahead and look at the APIs.
So-
I think we
It sounds like separate from the performance issue, you still have a usability concern.
Yeah.
Yeah. So
because-
you either put people into performance trap when they use some APIs, they get allocations, or you have to throw, and then you never know if the library you're trying to use, like if you wrap span into sequence reader.
Allocations aren't the end of the world as long as they don't occur in common cases.
Oh, they would, like, for example, to return sequence out of span, right?
That would absolutely
And
be
you can see how that would be used very frequently in parsers.
I
So-
don't actually.
Really? You
Yeah.
just slice out, like in
Because
JSON parser,
my
you slice out
understanding is that parsers are returning primitives.
a read-only sequence is a primitive.
I
Depends
don't- I
how
don't
much
consider
data.
that
No,
a
so
primitive.
there are
The
variable
primitives are like
length.
an
So variable
Oh,
length.
like,
it depends on which
things
level
like
parsers you have.
strings.
Yeah.
That's what he's talking about.
Well, it's not a primitive.
Yeah, that's an allocation.
Well, you.
Or you provide a buffer to write it into.
I
So
mean-
Asan is writing JSON parser.
Yeah.
Well, he does not want to allocate a string every time there's
Yeah,
a
or
JSON
as we
property of
discussed,
string.
you return a string, or the caller provides a buffer to write into it. One of the strings.
Yes. So now you let's go to the APIs
Yeah.
because I'm with you. I'm thinking that we can design APIs such that they don't allocate, even in the case of string.
So
Yes.
It would complicate, don't get me wrong, it would complicate the object model because now you have to kind of be more careful when you pull on the read-only sequence returning readme string, but I think it's a worth thing to
And
explore.
it also gets into this whole other thing that we were seeing as well, is that like because of how fast some of these things are, you add another argument to a method, and then you've hurt perf. Right? It's just weird that like it's that close. But anyway, can you roll down a little bit?
Yep, I'm
Just
trying to find
the.
the right window.
I want to show how
I used the
positive
mouse
works
now.
before we go down to the.
There we go.
So here, stop. So if you want to like pause the reader right now, this is the way you do it, right? So if you want to go recreate a reader again, right, at a particular point, you pass back out the read-only sequence. Because if you're doing async stuff, right, and you want to like get your reader back where it was again, that would be the way you would do it. So, and some of the other more complicated things, there's not much state that you need, right? You can reconstruct it from a read-only sequence, but basically that's the idea is that you stick the read-only sequence back out, and that's your
state
cursor.
Why would you
state.
not give them back the position?
Because you would need the position plus the original read-only sequence.
Yeah, but they passed me the original sequence, so they have it.
Hmm?
They have it. They passed it in to this method.
Sure, but
So
then
the
you're
caller
asking
has
them
it.
to track two things when they don't necessarily need to. That is an option. Right.
Okay.
If they want to, they can. I mean, you can do it that way as well. Sure. This was a. How do you do it in a single state machine?
The thing is, because you said that read-only. Okay.
I mean, you could also have like two methods, right? One gives you the remaining stuff as a sequence, one of them gives you the remaining stuff in the current span as a span. In which case, well, if I only have one span, then that's the only one I call. If I have the active position, I mean, even the position one, you can basically represent both the span and the sequence with that, and then you just
No.
Yes, it can.
should be
All
able
right.
to.
So key design considerations with this one had to be fast. The read-only span has to be cached, which we talk about this in order to get any reasonable performance.
Right.
Which obviously makes the reader itself have to be ref, even though the sequence is not.
Right.
And in being fast, that we want to optimize for things not crossing boundaries. So like whenever you're not crossing a boundary, it should be as fast as possible. Then we start taking hits when you're crossing boundaries, right? We still want to make that as optimized as we can, but like we don't want to take a hit in the don't cross a boundary
Right.
state if unnecessary. The other one's that there has to be zero allocation options for all functionality, right? So you need to be able to write code and then have it understandable in some way that you are actually, I've written code and it's never going to allocate on you.
Right.
So right now that's, I said, well, the methods that return a read-only span, you use those, you will never allocate. That was my bifurcation, but
You mean read-only sequence?
that's what I meant, sorry. The ones that don't return read-only span, I'm sorry, I'm not reverting, not doing the inverse. So the things that don't return read-only span. And I said, well, it has to support both UTF-8 and UTF-16.
Yep.
There is a problem here, which is another follow-up, is that like we don't have a UTF-16 parser. And the UTF-8 parser is radically different than our existing triparse methods.
Mm-hmm.
So we can talk about that later. I don't want to spend another half hour on that one yet, but like that's a follow-up. I think the most important stuff is to like start looking at the API surface a bit. And I had that listed down as having an issue.
But the UTF-8, UTF-16, maybe very briefly, what are we gonna do?
My suggestion is that we actually do ship the UTF-16 parser. That's my starting suggestion.
So another option that we have is basically rename this type to UTF-8 reader.
Except the person who doesn't want to ship multiple types.
Why would you do that? You could just have overloads in the same type.
Because doing the other alternative that Jeremy mentioned is expensive, very expensive.
Well, we don't basically.
Well,
we're not
back.
blocked.
If you rename the type, you still don't have the functionality, correct?
Yeah.
So this way, you could also just say, if we ever have to support UTF-16, we can just add members to this type. Because the cost is implementing it, not how you expose it.
They're extension methods right now. We'll see that. So like, it doesn't block.
Fair enough.
It doesn't block shipping the reader. It blocks shipping UTF-16 functionality.
What
Right.
happens if I instantiate a sequence reader of bool or a sequence reader of int?
You're fine.
But what does it mean to do that?
Whatever you want it to be.
I actually,
No,
by the way,
seriously.
I actually
I love it.
noticed that I didn't comment on it. I was like, is it worth it? Should we just make
I
it
mean,
bytes?
read-only sequence is of T.
Yeah.
Why are we?
But
Why would we make
let's
reader
look,
of
let's
T?
look at the
Well,
API
because
so
then
that'll
you
answer my
like-
questions.
it will
Yeah.
help answer your question because
Yeah.
like the functionality that is specific to types that we're understanding here, like
Okay.
the byte or whatever else, those are all extension methods.
Okay, yeah, that makes sense.
So if you want to do a reader of ints, fine. Like, and you can get the next
see.
data thing, you
Yeah,
can go through.
Okay, I
So
see what you're saying.
just in like when I started looking at again trying to reduce the amount of types,
Yeah.
like doing the UTF-8 use of the UTF-16 reader, it was just so awkward. And I did all the perf measurements and like, well, make it generic, and like, wow, it made no difference to make it generic. So, and it doesn't make sense to try and restrict it any further. But anyway, we'll look at that. So, and this is the last part of it related to the genericness, is that it's constrained to unmanaged and equatable, right? In order to get the perf, like you really can't have anything but unmanaged T, right?
Yeah.
Because we need to pin it or like get the pointers out of it to do the.
But what do you mean it's constrained? Do we support this constraint now?
Yeah, unmanaged, yeah.
Where T is unmanaged, T, or where T colon unmanaged, comma T colon inequitable.
It's right here. Okay.
Yeah.
It's
It
is awesome. I've been finding it really extremely useful in
Yeah.
a bunch of cases as I continue to like go through like interop stuff and all
Yeah.
that. So those are the key things. We look at the API surface area. We can roll down to that now. It's going to be more than one stream. But
Who's trying?
can you, Emo,
Yeah, like I'm fighting with the mouse again.
By the way, did we add the constraint to all the methods in like span extension methods?
No,
No.
Isn't it break?
Because it was too late, correct?
Early break, yeah.
When was the constraint added?
Post to one.
Yeah. Also, some
A
of
month
those
ago?
methods make sense.
It's C#, right?
When I was on sabbatical.
Anyway,
It's not
I see.
a framework change.
Okay, so let's look at that.
Yeah,
So
yeah,
I
I
guess
know, I
It's
know.
in 2.1. So basic bits, right? There's the constructor. You pass in the read-only sequence. We have our end, which tells you have no more data. And we have an advanced, and we just recently added rewind to it as well, because we found that that's super critical for like parsing a scenario.
And rewind over read-only sequence basically has to scan from the beginning, correct?
Only when it like doesn't have enough space in the current
Yeah.
span. So like most of the time, the expectation is that like the current sequence that you're in has enough space.
So is there a way to rewind without doing this by capturing my current position?
So
Because basically I imagine that parsers could do the following, like I'm about to do something that potentially I will have to rewind. So I store position, and then rewind takes position. And
Well,
then you don't have to scan.
You can
from
just
the-
make a copy
duplicate the
of
sequence
reader.
reader.
Well, but reader is very large.
Yeah,
yeah, but like
So
so
making
the reader is large. So like what my preliminary looking at this did, like trying to reconstruct from a position is just as expensive, if not more expensive, than trying to like copy the reader. The big optimization that we have here is simply that like what we do is we do the smarts of saying, like, you want to rewind this far, okay, you're in you know, the measurements are there from the JSON reader that we saw that it is pretty reasonably performant. Is that like most of the time you're in the span, you don't have to think about that, we deal with it for you, and if you're not in the span, then we don't even copy, right, in that case, we just reinitialize as if it was a brand new reader.
So do we have query APIs where the caller can say, is it better for me to rewind or copy?
No.
Will they know when to copy, when to rewind?
Well, it would never be more expensive to copy. That's my.
Oh, never
sorry.
ex-
Rewind would never be more expensive than copying.
What do you mean?
Well,
Really?
in
When
very
yes,
rarely.
when your read-only sequence is super long, has many segments, it will be very, very expensive. It can be potentially very.
If you're
very-
going to go through a whole bunch of them,
Yeah.
the presumption is that like if you're not going to be in the current span, most typically, and I actually didn't call this out. I should have. I probably did for it later on. Is that like we're also designing around sequence sizes of something around 1 to 4K, right? So like as far as guessing, like how often, or trying to predict how often we're going to go across boundary levels, and how much we have to optimize for those cases.
But it's not. I don't think it
So-
almost matters. Let's say, as long as I read a lot, if I need to rewind from the beginning, it's gonna be costly.
yeah, but then you're in a bad place anyway. Because
So, like,
you're
there-
holding
there-
on a lot of memory.
You shouldn't be rewinding 2 gigs. That's what you're saying.
Mhm.
So
Like, you're keeping 2 gigs in memory already, so you're pretty.
Okay.
So and there is another thing on this
Slow.
as well, is that like the expectation is that like with the other APIs, rewind is not something you have to do very often. It's an error state type of scenario that you're in. So like one of the things might be you need more data, right?
Okay.
And like
What
you-
was the use case for rewind?
so
If you have partial data and you try to read something and you find it's incomplete, I've already advanced the reader too much, so I need to rewind back
How
when I
do
advance.
you stick new read-only sequence into
Okay, it's a
into the reader?
It's a typical parser thingy. So parser goes, parses
No, I
one
get
branch
it.
of the parse tree, and basically then decides, oh shoot, I'm in the wrong branch, so it needs to rewind and try another
But
one.
when you call pipe redasing and you get new read-only sequence, how do you, like, in theory, while it works right now, in theory it can give you completely new read-only sequence with the same data. It doesn't supposed to, like, as soon as you
Yeah,
call
but if you
redasing,
advance, oh, I see.
you invalidate all the positions and all read-only
the,
sequences, right?
the presumption is like if you're going to the pipe, yes, you have to restart your reader again completely.
Yeah, but
But
who
you can
else?
take
No, no,
the
no.
you can take
The thing that you're missing is this doesn't advance the pipe for you.
yes.
No, I know.
So you only advance pipe when you reached a stable point. So your parser is parsing. Well, I successfully parsed whole method. I don't need to. I know I
Right.
don't need to rewind. Then you advance pipe. So you never advance pipe unless you in a stable point and you know that you will not have to backtrack. But when you have multiple branches in a parser and you think that you may need to backtrack, this is the method to do it. But you never advance the pipe.
But why do you need to backtrack then? You're saying you need to backtrack to get more data.
No.
You can just-
To
so
basically
what-
just, you know how parsers have different branches. They don't know yet
I see.
whether it's gonna be an expression or,
I see,
you know,
okay.
like from the first return, you may not know in which branch of the parser you are.
So, yeah, some of this will make a little bit more sense with the rest of the methods too.
Yeah.
So, as to why you might rewind, we believe we can characterize it within these other methods, and you can give an actual real use case.
So rewind, is this the right name for this method?
Well, there's something called advance.
Like,
Retreat.
That's what.
yeah, I actually started with retreat, and I went from retreat to rewind because retreat seems like a little more loaded. Like, you know, retreat.
Advance argument is a sign long, so you can just negative advance.
I mean, the nice thing about rewind, like advance, is the name indicates it's changing the state of this, right? So,
I didn't want to put them together because there's also, like, we can add more documentation
Why-
on rewinding, like,
or-
in not have it be muddled in the other one about, like, this whole thing about having a whole bunch of sequences, right? You know, so
or
it's-
why not just allow you? Well, advance takes a long. Why not just allow passive and negative argument?
for the
Just said
reason I
that.
just gave you.
Oh, okay, sorry.
So,
Okay, let's go
Anyway.
with rewind. It's kind of weird, but
there's also, I'm also thinking that, like, this would actually be, you know, if you accidentally advanced negative and you didn't really intend to, there's something in there that helps kind of shake out parser issues. Like, consume gives you the total amount that we consumed, and of course advance moves that forward, and rewind moves it back, and changes the other state. Current span is, of course, the current span that's cached. Current span index is the index within that current span that we're in, you know, related to the consumed into this index. And unread span is the convenience thing that gives you the sliced version of the current span.
Do we need the unread span to be public?
Do we?
Yeah. Like
You
anyone-
don't,
It's current span, not
technically
slice.
have
yeah,
to,
yeah.
but like in the case of at least not in this implementation, in the span reader implementation that I have, the actual backing thing is just current span and unread span. The other things come from that.
But even then, it could be an internal implementation detail. It doesn't have to be public.
Well, then you would have to slice it to get the stuff yourself.
If I want it.
Yeah, but you do in a lot of cases,
Okay.
right? We see that all the time. So, like, in our own logic that we had to write for all these extension methods and things, that you're getting the unread span because you want to deal with the unread span yourself to do really complicated parsing of them. So, you would want to avoid extra slicing where it's not necessary, and that's abstracted away, right? By getting the unread span. Because in the case of a span reader, you never slice when you're getting this.
Is the concern that slicing is a performance hit?
It is yes.
Do you know where the hit comes from?
Slicing.
But what part of slicing is the hit? Is it the bounds checking? Is it something else?
It's I think it's primarily the bounds checking that, like, is the costly part of slicing.
Because you could elide the bounds check here.
Hmm?
Like there's no reason to change our API just because we perceive that something is a performance hit. Like we control the JIT, we can always add APIs to span that are like dangerous slice. We can do that. Like we can make it so that we don't have to change the APIs here just because we perceive performance problems elsewhere in the
Sure,
BCL.
technically, I don't think this is a big deal, but like, for you're having unread span.
It's just the two of them together seem a bit weird.
If I were to get rid of anything, I would say current span, but like,
Sure.
just, I don't know.
I think current span helps to understand what current span index is.
Yeah, well, you wouldn't have
Imagine
that, you
that-
wouldn't have that either if you were.
Yeah.
Yeah,
Because
well-
why do you care? Like you've already consumed the data from that span. Why do you care? If you care, call rewind.
Well, so
Back,
Yeah,
back to
like-
the rewind.
Yeah.
Sorry for being about 2 minutes behind the conversation. Could we condense both advanced and rewind to be like seek or seek2 like we have on like StreamReader? So like StreamReader we use seek and you pass in a negative offset if you want to rewind. and that's what we've already shown
That is a
everywhere else.
possibility. We could change it to seek and combine them.
Just because then it's consistent with the existing like.
You would also
there,
want to
there,
take
there
seek
is
position.
the sort of difference with this one is that like seeking backwards does have a performance issue with it.
Just like with streams, right? Or they can
Well,
throw if they don't support like the rewind.
Well, there's the non-seekable streams, but I don't think they have the same sort of performance. If you're going to seek back a gigabyte, it's generally the same sort of thing if you seek back like 8K or whatever, wherever you're going outside of a page. So, or what's in the cache or whatever, right? You know, there's.
But do you think the
Here it
method
makes
name
a difference.
rewind implies that it has different performance characteristics than passing a seek with a negative offset?
Well, I think that's.
Anyway, I'm just throwing that out there. That'd be
Yeah.
consistency with stuff that's shipped like 15 years ago.
And I agree. It's just like I can go both ways on it, but like I think that there is some value in rubbing people's face in the fact that that there's a different. Just like we don't make something, we don't want properties to have hidden crap on like how much on performance or whatever, or changing state or whatever. There's a by having separate methods, it kind of lets people's face into the performance differences.
I don't know. If I didn't read the docs on this and I just saw advanced and rewind, I don't know if I'd necessarily know that rewind is
No,
much
but
more
like
expensive than
there's
advanced.
also the thing if you're going in and like auditing stuff, you go back and you look for all the rewind stuff, and finding negatives is not so easy as finding all the rewinds and like double checking to make sure that like they're not being using them in ways it's that sort of thing.
What do you think, Christoph? You probably created the seek method the first time around.
Well, so I know that advanced is also super performance
Yeah.
sensitive, and he would have to have a branch and basically say like if the number is negative, I do
So you like
something
this?
else. Today advanced, I assume it's basically
Still
just
have a branch to verify that it's
Not
more
negative,
than
or-
not negative.
That
Well,
branch
it-
is going to be skipped most of the time. The branch predictor will just say no.
Wouldn't it
As,
still be
so
skipped?
does the other branch
Yeah.
in the other case, right?
Yeah.
Like we're talking about exactly
Instead of
the
throwing an
same,
exception, it does
exactly
something.
the same if.
Yeah, but don't you do normal U-long cast on the other one, and then just say if the number is outside the bounds, you fail. Versus now you would have to handle negative and the out of bounds separately, so you have more branches than before.
Yes. If you had a
you
seek
would
method,
replace
yes.
that with
It's just,
Yeah.
So seek would potentially, and advanced, by the way, is like probably the most critical performance.
Yeah.
But I
sensitive.
mean, we
Right.
can take it as a note and basically
take it as a note.
Yeah, yeah, yeah.
consider.
So-
there are some other things. So we use advanced
So-
terminology
Mhm.
in pipelines,
okay.
and which means yes, we would be consistent with stream, but this is not for reading streams.
Yep.
It's for reading pipelines. So that's another negative. But we should, it's.
I should look at the perf on it to see because like again.
No,
like,
no. I mean, consistency with pipelines for me trumps consistency with streams, personally. But
if we get more
um,
feedback on it, I can look at the perf because that would be the other thing that I would say.
It's just
'cause-
a note, something to consider as you evolve this.
Because advanced just again like is like the most perf critical piece in the entire language. Like because calling advance happens a lot, right? And sometimes a ton if you're reading small data, and that like really shows up. Any changes we make to advance, we change one little thing, and then it would make a really measurable difference on the day somebody.
Why is advanced though super perf sensitive? Because most people, I would assume, would just call the try parse methods and then the thing internally advances, right?
Yeah,
I'm
yeah.
not calling advanced.
But
or
advance
advanced.
is in the hot path now as an implementation detail of these helper methods.
Yeah, but he doesn't have to call advanced. I mean, you can have his private version of that is more
Yeah, you could
efficient.
have
But
your-
oh,
And
but-
that's
you could
the
have
thing.
a
We
small
tried to
advance.
do it. We tried to make it more efficient, and we couldn't.
Well, also it cannot be private because it's used by the extension
Yeah.
method. So
Oh, because of the extension.
at best it could be internal, but then we don't allow people to write, basically add
Okay, that's fair.
functionality. Let's say
That's fair.
somebody wants to invent a new format.
I see.
I did try to like make
I
it
don't know.
like
I
make
think
make an internal one that like didn't do any validation.
This seems reasonable.
I think you should just measure it, right? Like we were talking about a single if
Yeah.
changing an if that throws.
I
that does
did
work.
actually measure on this one, like trying to do because we were just even discussing this. Like I like split out where it did no bounds checking
Mhm.
for the internal one, and that like just having the other method caused the JIT stuff to add an impact on the other side of it. So this stuff is all really.
And rewind is such a rare case.
Yeah.
So in any case, So that was that. And then we have the position here, of course, which is the current sequence position, current, like if you want to be tripping with that, and the original sequence. And
In terms of naming, I'm just like, sequence position is called position, the read-only sequence is called sequence. So now it's like, should it be more specific, just say one is the sequence position, one is the read-only sequence? Because sequence position, like the name sequence position is split between two properties. One of them called sequence, which is a read-only sequence, and the other called position, which is a sequence position. Right?
Maybe it would make sense to have that as a method then, which just gives you both, rather than having them as properties.
position.
No, you can use them separately, and like just copying entire sequence out every time when you don't need it might be expensive.
Well, getting the position actually constructs it.
Okay.
In this case, it does a slice of the other one. This is basically convenience then.
Okay.
So really, what you're doing is this thing is just a convenience for. So we don't even really technically need the position. Sorry, the position is going and doing sequence dot slice consume. Right.
The other thing about exposing all of these properties is you're going to have to guarantee for all time going forward that getting these properties are very, very, very fast, which is going to bind your hands a little bit in what kinds of internal implementation detail changes you can make to this type.
Yeah,
Sure.
along those lines, like, are we spilling implementation details purely so we can make this off T and have extension methods against byte? Because if this thing is
No.
literally a reader of hard-coded to bytes, there could all be normal methods on the thing. In which case, you don't have to expose most of these things. You can all be implementation
but
details.
not
But you would.
like things are useful without. Other people would want to write extension methods that are as good as ours too. Like if
Yeah,
Castro
but
wanted to
what?
write a try parse method that is as fast as our internal one.
A try parse method of what? Because basically, if you're reading a reader, right, like you expose the primitive types, at some point this is complete, right? And then the only high-level thing is like things that are comprised of these primitives, right?
No, so imagine that somebody wants to write a binary big endian set of extension methods that treat the bytes as big endian.
We already have that, but yes.
You have that. So I mean, but you imagine that you invented your new binary format.
What I'm saying
Reader
is
has
no
bytes, and
open-ended
basically
field,
now
right?
just add a namespace with extension methods that read your whatever format that
So one. Oh, sorry. Go ahead.
Because there's another issue not to completely lose sight of here, and I'm trying to get my head around, and I'll catch you later for a broader understanding.
Sure.
At some level, as we go out from our core, fast stuff, at some level we go out, we need to make this accessible to other languages. And one of the things that makes this not accessible to other languages right now is the use of the unmanaged constraint. So if we go against the types, we remove that problem. Now, I'm not sure that's the only problem here, and so it could be that we need to impose that one layer further out in terms of other languages using this with extension methods and other things that are accomplishing the goals. Things like the pipeline stuff that is going to allow those goals to be met by the user. But we can't have Visual Basic users be unable to parse faster than what they're doing today because we used an unmanaged.
So the
Constraint.
unmanaged constraint, I assume, and maybe I'm wrong, is completely ignored by other languages, correct?
Yes, but would this work if you had a language that declared a type that didn't have that constraint? Then wouldn't that make this unusable by that?
CLR in theory
No,
would throw
yeah.
when validating the
And-
type.
Yeah, you would get exceptions, but it would work.
I don't want us to derail this too far. I do want it to kind of be in the back of folks' mind. We can have a separate, like, the people that care, sit down and see what's workable with Jeremy from a Visual Basic and other languages perspective.
But isn't the primary problem in VB you can use span anywhere?
Well, that's what I'm trying, that's why I said, as we go out, first of all, as we go out from the core, how we're doing it, to what's the user accomplishing, at some point in there, we need to include the other languages, A and B, it may have span. We may add span
It's not
for,
just span, it's anything that's a ref struct, right? Which includes pretty much all readers we have so far, because they're all ref structs.
Yeah,
You wouldn't be able to use any of them from VB right now. Your constraint is probably the least of the.
Yeah, well, so
okay,
the ref
as I
part.
said, I'm trying to get my head
Yeah,
around
sure.
where the boundaries are here.
So
And
This is a solvable
that's a
problem.
problem.
Well,
The-
but I think so. So
That is
forget
right.
about the unmanaged
Yeah, I missed that
constraint. I think it's a good issue that
Right.
we are kind of like adding these types that potentially cannot be used from VB.
Well, and I have to say that one of the things that, and it's
And-
VB in other languages, if somebody creates COBOL.NET Core, then it's going to be COBOL.NET Core as well. So I do believe that as we transition away from writing Kestrel, doing the things we need to do that we're going to do with C#, as we go from that to what's our users realistically going to do, which is I've got a huge, great, big, long file, and I need to parse it in this manner. Someplace in there, we have to adopt the other languages.
Yeah,
I don't think it's necessarily at this point.
Yeah, it's
But-
almost like the other way around, right? Those other languages have to adopt being able to use span.
Well,
I think they need
well,
to-
that's-
they need to
that's-
catch up.
That's very unlikely to happen on
Okay.
any other language than
But I
C#
think that,
and-
Yeah,
but I think
sure.
that's a like
That's
to the high level point, right? Like we're not doing really net new stuff here, right? What we're doing is we do the things you could have always done with the frame. We can always read ins and uins and datetimes and whatever, right?
Yeah.
But so we just make the 10x faster or 100x, whatever the factor is. And in order for us to do that, we had to change the type system and other things to get to that perf, right? So like the languages can still do these things. It's just that if they want to get the extra perf, well, then they also have to do work.
Okay, well, I don't want to
I
derail
think
this
that
right
would
now.
be
I could respond to
fair.
that. I don't think that, again, it's what our users want to do, let's make that fast. What we need to do, let's make that fast. Someplace in between there, we have to
Yeah.
transition.
I want to piggyback on that and say, like, we don't want to design something very specifically for Kestrel.
Totally.
That one I would agree with.
Very,
Yeah.
very specific for going fast for systems thing. I completely support that. Kestrel is our poster child for a broader set of purposes, and happily, by having a poster child, it's easier to think about. So
Sure.
I think, I agree with you, but
So
Yeah.
that's a bit of
I missed the ref in there, sorry. That was
separate
my
discussion, but that's like a CLS discussion, correct? Like
Yeah.
we kind of stopped doing CLS, caring about CLS.
Well, that's I
And-
mean that's the thing we had a side conversation on a while ago. Yeah, we should, like I think we understand roughly what the difference is between languages, but not in great detail. Like I mean, we screwed over F# by accident with the implicit conversion, for example, and like this is one of those things where having a list would be useful. I'm not sure CLS compliance as it is the right way to do it, but like I think the spirit is it.
No.
Right?
But having
But,
having a detailed list, because I didn't know.
CLS v2 is something we should talk about, that it is not any place similar to old CLS.
Yeah.
Yeah.
It's restricted. Okay, anyways, I did not mean to derail it.
It's all right.
but,
Well, that's
uh,
useful for me to know, because like.
And I
just
do want to have a
assumed the rest
separate
of it worked.
conversation. I would like to have a separate conversation with you
Sure.
about this.
So I think so that just to wrap this up quickly,
Yeah.
like I think my high level approach for this would be that what I would hope would happen is that some of these APIs that we have today that deal with spans and readers and low level stuff basically allow you to write fast parsers, right? In a hand-wavy motion. I would think that there's more high-level components, let's say xdocument.read or other things that VB can still use, and the implementations of them happen to benefit from these fast methods because they just are now allocated, less allocated, right? Same is true for ASP.NET. At some point, I would think there's some middleware that gives you access to more raw data structures, in which case a VB person would still be able to compose middleware, but they may not be able to participate in building middleware, right? And so I think that's one of those things where you can probably draw a line and say, yep, some things are inaccessible to VB developers. The question is, do we believe that's acceptable or not, right?
What you
And then-
did is put different
yeah.
words around what I was trying to say with this notion of the core,
Yep.
and then as we go out to the user purpose. So you just.
Yeah, I think
agree
the
with you
Agreement.
completely.
yeah.
Agreement!
So,
What is that second overload of peak? The one that takes a span.
that's what we're going to right
Yeah.
now. So, let me just finish this one.
Yeah.
So there, you have try peek, which is very simple. It's just,
Yeah.
I want to look at the next byte. You tell me what it is, whatever. Like it might be in the next sequence that's possible. Peak, and this is one of the weirder things, but like, and this is all around the like trying to come up with something that doesn't allocate, right? So if you want that to be performant, you don't want to be allocating. And like typically what we're doing with peaking, certainly internally, is like you said, like, well, we want to read out a date time or something like that, right? We need this many in binary format. We need this many bytes. We can just stack out that many bytes, pass it to peak, and peak will either copy into it if it has to, like aggregate, or it will just return you a slice for out of the current span if it's already contiguous already. So this one is a
Why
little-
is it peak? Why isn't it read?
Why isn't it read? Because it doesn't advance.
So
What-
sorry, go ahead.
Like, what's the point of peaking a bunch of data without advancing? And we also have
What's the-
rewind.
Well, now we have rewind. That may help. The only thing with peak, of course, is that you haven't moved forward. You have to rescan the entire thing again.
Yeah, but you have to move. You'll have to advance later. That would still rescan the entire thing, maybe.
Yeah. So like here's the like when we peak. So this thing will return whatever data is left. So like if you were trying to read out a datetime, if you didn't have enough bytes, you'd get back a span that was too small, and we fail, right? Because we can't cast to that because we don't have enough bytes left,
Yeah.
right? Other things where we use this, we look to see we use it internally for a lot of these things. We want to see like you asked for this. Can I pull this together and look at it in that framework, or you get it out yourself and you make a decision about this is the whole. Rewind can be expensive, right? But peak can tell you, in his particular case, and actually I should bring this one up, is that like he finds a quote, right?
Mhm.
Moves past the quote and starts to read to the other quote. Now he may or may not hit that other quote, right? And we have a method for that. So, he's stuck at rewinding in that particular case.
Well,
Other things when you're reading, like you may be reading to see like, is there a carriage routine line for? Is it a CRLF at this point, right? You can peek to
But
see
where are you
Okay, here's
reading
the-
into?
Here's the main scenario. I'm writing a parser for a language, and I want to check whether the next, identifier is 4. I pick 3 characters and compare it to 4. And I can do it without allocations and very efficient.
So and we have a lot of helpers here that deal with hopefully the most common cases for peeking ahead.
Like in that scenario is next.
Yeah. So,
Yeah.
but like
Oh,
we didn't want to write.
this next is pick and compare.
Yeah. So like there's.
Oh.
And it's even more optimized, right? Like the one that's here doesn't have to compose it. Like if you're
Yeah.
composing on the other, we don't know what you're going to do with it on the other side for peak, so we have to put it together. For is next, we don't have to actually copy it all. We just look, right?
So the parameter to peak is a scratch buffer, and the read-only span that you get back from the peak method will either point to within the current span or into the scratch buffer that you
Yep.
passed in, and the scratch buffer will be populated.
Yep. So hopefully, like these other extension methods deal with most of the cases that you need to look ahead, but
So-
or the most common ones.
I believe that overload of peak actually leads to performance problems in the common case because for someone to pass in a scratch buffer, almost certainly they're going to be stack allocating that scratch buffer, and it's going to be very common for people not to have the attribute that says don't zero init locals, which means that the compiler is going to have to pessimistically zero out the scratch buffer just so they can pass it into peak on the off chance that they happen to be crossing a segment.
So there's this is kind of like one of the more advanced APIs that are on this, and
Yeah.
I have a rather detailed link. But like so, in some cases you may want to be you may want to be reusing a scratch buffer, for example. Like you get something out of your array pool, or you just allocate once in your reader that you have your scratch thing for looking at scratch stuff. This one has already quite a bit of XML comments on it, but
Okay.
it would be. These sorts of things are definitely a concern, and that's
But there are
and,
ways
and
around it.
incidentally,
There are ways around it. Yeah.
And incidentally, this is like a big reason why I think these ones are important.
Yeah.
Is that like saying like, well, in most cases, don't want to have to mess with that,
Sure.
like, and we can get around that.
So I have a question about the peak. Other scenarios where I need to know whether you copied or not. Imagine that I
Well,
want the copy. I want the copy.
I couldn't think of any.
So you return me read-only span. How do I know whether you actually copied into my buffer? That
Why
I
do
passed?
you
Do
want
an
the
equality
copy?
check.
I don't know. That's what I'm asking.
But like you cannot. Nothing else can modify the span
Yeah.
because it's stack only. So you don't really need a copy. Your own.
I
You
couldn't
don't
think
need
of
the
one,
copy.
but maybe somebody can.
Yeah.
No,
Somebody passed me a buffer.
I see, and it's being
And
modified
they said,
on the backside.
copy the next int into my buffer. Well, I
Without
thought-
advancing?
Maybe without advancing.
So that's what operator equals is for on span.
I wonder whether basically
So
then you just...
does that actually check the equals equals?
It's reference equality.
All right, so reference equality will do it for you. Okay, great. There. I don't think people would be doing
But
that.
I have an email
read
saying we
for
should
sure,
kill that
but,
operator.
Does it work between read-only span and span?
Yes, it should. Because span is
Because we
implicitly
just
convertible to
compared a
read-only
few.
span.
Yeah.
It
Okay.
should work.
I think it would actually work.
So try read is actually the only method that's in the buffer reader at the moment. Well, unless something has changed since the last time I looked at it. So that just reads out the next byte, or whatever T is. Nothing complicated there. Is next, right, is like, well, you could technically do this. One of the things we found in iterating with the JSON reader experiment is that, like, making a second call to advance or not advance, like trying to deal with it, like being able to aggregate those when you need them aggregated has a very measurable impact on your parsing.
So why don't we call it, like, we have this concept in some existing APIs and we call it usually starts with.
We could.
Because it's a reader.
I know.
Other APIs
that's
are
just a
more
bit
like
weird thing, but you
the
could kind of
entire thing.
pretend that the head of the reader, the current position is the head of the reader.
yeah. I
Yeah.
never.
Quick question, what happens if you call peak, not try peak, but peak, and you're at the end of the sequence?
You get back whatever is left. So we do that logic in a fair amount of places. I was just saying like that with the binary thing. Is you give it this stack alloc 4 byte thing,
Yeah.
and it comes back with that's another reason why we get the perf bits, but like you get back 3 on the real span. It's like if it wasn't 4, then I know I'm done, right?
Okay, so if it returns less, if it returns fewer than the length of the copy buffer,
You're
it's a
at the-
contractual guarantee you're at the end of the data.
Yep.
And you don't have a read method, you only have try read?
Yes, because you may be at the end.
Yeah, but what if I want that to be an error?
Then you throw.
Then you check.
It's faster if you throw the exception rather than have me do it.
Huh?
Read, so exception handling is actually faster than doing if checks in languages like C# and C++.
Not when an exception is thrown.
No, but if in the happy path where an exception is not thrown, like not having any if statements at all and letting the exception dispatch logic just unwind the stack is actually the fastest thing you can do.
He has to have a check inside to know whether to throw the exception.
He
So
already
the
has a check because try read needs to be able to return true or false.
Okay, so then you're saying if this boolean is true, you're saying exception would be faster?
Yes. I mean, we're talking about performance above all else, right?
Well, but
So-
the performance is if I don't want to, basically it returns false and I want to do something else, then throw an exception.
Yeah, then you have try read, right? For that.
Oh, you're
because
saying,
you- yeah.
so you want
But
to
you have,
both
but you'd have to
have-
does it wrapping the try catch on the other side like impact the jitting? I mean, that's what I
Yeah.
understoed as well.
Yep.
So they
Yes.
can't optimize in the same way.
That's
if
right.
you're-
Correct.
So you're just kind of paying
Talking
it
about a
up.
micro
Yeah.
optimization, maybe.
So
No, what I'm you're also taking into account things like, well, now the call site is smaller, so now maybe it's also a candidate for inlining, stuff like that.
Are you proposing that we add a read method that throws?
Yes.
That is basically equivalent to
That
this
is
one?
exactly what I'm
I would
proposing.
want to see a scenario where it actually adds perf.
Okay.
Improves perf.
I can get one for you.
Sounds good.
I will make one for you.
sure, please do, because like
Just add it as an
now the only other comment I'd say
It can't be an
is-
extension method.
The
That's
only
the thing.
the only comment that I would say around that is like currently there is no throwing on any of the methods that is not like bad input.
Yeah.
Yeah.
So this would be the very first one that it's not really bad input. So there is throwing if you like go out of bounds, right, for like advancing and stuff like that. There's throwing if you like pass in a format character that isn't supported.
Yeah.
It's that sort of thing.
Yeah.
But you can't throw from any of these other ones.
Sure.
It's like, there. So,
But that makes sense.
and like while both of these like is next things could be done with peak, This is, as you mentioned, like when you're creating that buffer, you're getting copies in some cases. This one would never copy. The is next just like does the right thing and looks. So it never allocates, never copies. Are any next? I called this out down below, down below, but like from a performance standpoint, and this is an iteration again with Asyn's consumption, is that like doing index of is becomes much more expensive if you're doing like 1 through 4 checks. So from the performance standpoint, having those is measurable.
And by the way, if you use the starts with technology, you could do starts with and then starts with any. They would be kind of all grouped together. Nicely.
Okay.
Oh yeah, okay.
Next anyway, yeah.
I'm torn because while I like them all together like that, there's something weird about starts with, like it sort of infers that it's starting from the beginning of the buffer rather than your
It's
current
not a
position.
method on the buffer, it's a method on the reader.
I mean the reader itself, like
I know,
where's the beginning of the reader? So
it's a bit weird.
I'm like,
but okay, I have to tell you also, like, people were talking about and you were discussing is next, and I couldn't think of what is next is doing. Like without looking at the signature and now seeing the method, and I didn't see it in the original proposal. I kind of, David was talking about this next. I was like, we have is next. Like, what is it doing? And if you said starts with, I would immediately know what it's doing.
it starts at the beginning of the reader.
Maybe that's just
This is subjective. I'm fine
so
with
take
like
it on,
consensus when we get
leave
it, but like
I get the next terminology though. It makes sense.
it's not something we have much of now. This terminology, so that was the only awkward thing is when I was trying to pick these out, and I iterated through a few other things that were really obviously worse. But that's what, so like skip past.
Can you try to figure out why not? Like I'm looking through the source and advanced past. Why is it faster to put it inside than to put it outside of the method? Like it just calls advance inside the method for the true cases. So why is it faster to put it into the?
Sorry, what method are you discussing?
I'm talking about
why
advanced
the
past
advanced
argument. Yep.
Oh,
So what it does, it just does if on the result and.
Yeah, because it's all internal to the struct. The jitter does a better job with it.
I don't understand. Otherwise, if you don't have this parameter, is that what you're proposing? Then you have to, it advances once inside, and then you have to...
No, it doesn't.
Yeah, it does.
Why would it advance in is next method?
Because you want to know, like, logically why you would want to?
No. Like, why... If I had is next without advance, without the last argument.
And then you just call advance.
Yeah, when I want to.
Yeah. So, like, because of the perf thing.
It's strange, because, like, looking at source is just another if that calls advance.
Yeah, but it's calling advance internally because it's in the struct.
I know, I understand what you're saying. I kind of have to
like,
say
should we obfuscate our API that much because of the thing that might be fixed in the next version of JIT?
If you remove it, starts with, totally makes sense without this parameter. What is starts with and then advance?
Yeah, that is cleaner.
What is cleaner?
Removing the advance past parameter and just saying if the caller wanted you to advance, as you were saying too, like just make the caller call advance.
It's measurably worse.
But only in the current JIT. Like that's something we can change in the JIT.
Sure.
How much?
I mean,
what's the performance overhead?
Do you remember what we were saying?
No, I don't.
It was like a month ago or whatever that we started adding those. I think it was at least like 5%.
Like it doesn't use any pre-calculated state or like internal data that is only available inside the
No, I get it.
calling.
Sure, like
So,
these were all measured. We didn't start with these. By the way. Like it was all.
I don't think in my scenario I've ever called with advanced true.
Well, this particular one, no, but we added this whole advanced true or false thing.
Oh yeah.
Totally based off of measurement.
Yeah.
Does
But
it,
he says that
yeah.
he doesn't use it.
I didn't
No,
use it for
in
is next.
this method.
So I don't want to rat hole on this question too much, even though I'm going to ask it. Is advance inlined into the caller in the common case?
Yeah.
Yes.
Okay.
It's marked as aggressive inline.
Okay.
Yeah, so
But
it's
it's
another
still-
argument for moving out of the method.
But it did measure, so that's it. I mean, like I'm
But
fine with
yeah,
removing
yeah,
it.
yeah.
It's just there is a perf impact to it.
Yeah.
But how did you measure? Did you measure in a loop just calling this method? Or what
Probably
method is
benchmarked
it
on
calling?
that.
It was
what method
measurement
are you
on-
I
calling?
think it was skip past any or the try read 2. those
Okay,
ones.
so I buy that one.
Yeah,
So
yeah.
try read, I totally buy it.
Yeah.
And the reason for it is that read has to advance, and then you optionally have to advance the delimiter.
Yeah, that's
So I
Yeah.
completely agree that you want to do it in one step. This one, I'm skeptical.
like it's, in picking methods.
Yeah.
You're turning pick into read.
And I was
condition
trying to
and
be consistent, but like that's fine. I can remove it. I don't care. I mean, it's just like
Yeah.
in the micro benchmarks I was seeing it, and it was in the other ones it definitely made a difference.
Yeah, no, don't get me wrong. In the ones that advance, like try read,
Yeah.
skip delimiter, totally makes sense. Because you're gonna be advancing either once or twice if you have this parameter.
So one of the things that I was told when I was working on all the UTF-8 stuff that I'll repeat here is like I was told stop doing clever things in code, file bugs against the jet.
Sure.
Like and Andy loves getting bugs.
Famous last words.
That's just general feedback for any PCL feature.
Yeah.
Like we should.
Yeah.
And I'm trying to like balance
yeah,
between.
Oh, of course.
This is I found something that's extreme. So like
Yeah.
when I was
Yeah.
iterating with that, so like when we see things are like 2 or 3%, we're like whatever.
Yeah.
Okay,
And,
yeah,
and to be
I will-
and to be perfectly
yeah.
honest, like it's when we're talking about like internal implementation details, like maybe it's better for us to be clever because maybe someone like Andy or Carol is backlogged. But if it's going to start affecting the public API, like this is weird.
Okay, so I'll give the scenario for why is next advanced true. So I'm looking for a known span, known value like null. And I know if you find it, just advance faster. So
Yeah.
I was going to do that anyway.
Yeah.
So it's more of a convenience thing rather than me having to say is next and then advance. Like I know I'm looking for null. You told me null exists, advance faster.
Yeah,
I
but
think convenience is not the goal.
then it should be read with the takes a span and then we just compare it and say
Yeah, it seems like an arbitrary shortcut too, given
Yeah.
that all the other work is so much more complex. Like doing the if check and writing another call seems,
So
That's
that's
Alright.
fine. I mean, you're good enough. I think that one's clear.
yep. As soon as I have my mouse again.
So here's the rest of the stuff that's part of the class. The other things are the extension methods. But there's try read to, where we're reading to a delimiter.
Yep.
Right, and there's the advanced thing which we've gone over. The other sort of option here, there's of course the one that returns a read-only span. Wait a minute, which way? I said the sequence and the span ones. These are the ones that return. This one will allocate if it has to, because if it doesn't have a contiguous span, it has to make one.
Yeah.
The expectation is that like for a lot of people that doesn't matter because like you're crossing at a 1K boundary and like you've read something else.
Well, but another option is the parameter is not an out, but an input parameter, and you copy. So you don't allocate,
but
but you
there's
copy.
in the normal case when you don't cross a boundary, it's just a
I know.
slice.
So
Yeah,
that's
there's
the
no copy.
trade-off, and I wonder whether
do
we don't want
this
some.
pattern
copying
is
is
all
pretty
over the
expensive.
place. Like if I need data, get me stack alloc span and then stick it into a method. Did we try to approach it on like language level?
What pattern specifically?
Like reading something, this pattern where you can either get a span or you need to allocate a span and let something else copy into it.
This pattern
It's,
doesn't actually exist all over the place right now. Like
Really?
maybe it exists internally within like some of our internal code bases, but it's not a pattern that's generally recognized across the BCL.
Because if I wanted to optimize out this potential allocation, is there a way to do it? Can I write a complicated, if statement that checks whether I will be crossing the boundary or not, and then either allocate or copy? I mean, either just get the span or copy.
You'll do this
like
first.
I was doing at peak, we could have something pass in a scratch buffer and like stuff like that, or some callback or something that allocates. Like one of the thoughts is that we have blow out the size of the thing even bigger and have you like pass in an allocator. Right.
Well, to answer your question, the way that you do it right now is you have access to the underlying span, call index of any, on the delimiters.
Yeah.
And if it returns, I didn't find anything, you know that you're about to cross a boundary.
So yeah, but
But then I have to repeat the.
Well, you asked to zero a for a caller to know, and
Well,
that's how.
Yeah. Okay.
So, but as one mitigation thing, I thought, well, one of the things we could do is we could actually have you pass an iAllocator of some sort that would actually do, like, because right now we just arbitrarily make a new array, right, whatever. Like, if you want it, if we have something that like provides that, whether it's a func or whatever, but like, we could do that as a possibility.
Or we do what you said. We do the same pattern as the peak.
Yep. But again, you know, it's not free because like adding yet another, well, from both a complexity and a performance standpoint, because you know every if you have something that takes one argument, like the jitter has a very easy time like doing inlining and whatever, you know, like when you get up to like 6 or 7, it's like or like being efficient about passing parameters.
Yeah,
Talk about
yeah.
that. So like there. We got to pull back and forth on those things and see what works best. So that's why I was kind of thinking about something like global for allocation, some callback, but
Yeah.
there are drawbacks to that as well.
No, then I need to know whether my thing was allocated or not. If I want to pull it,
Like the thing with returning read-only span is you allocated something on the heap and you know it's on the heap, but you cannot get it out of your stack, and now it has all the disadvantages of the span and it's also on the heap.
And also, like, you know, this is kind of the main pattern that we have in many of these APIs is that the callee never allocates.
Yeah.
And this is an API that not only callee allocates, you never know whether they did or not,
And the thing they allocated is not useful past the stack.
and the thing that they allocated may not be useful.
But again, with the like 1K 4K sort of boundary thing that we're talking about, and the expectation is that like very rarely will you allocate, and when you don't allocate, this is very very fast, right? So if you're within the sequence, because it's just a slice.
So quick question, on try read to, so say that I call try read to, comma, and that will by default go past the comma. It only goes past one comma, correct? It doesn't keep saying, oh, here's another, here's
Yeah.
another, here's another? Okay. So skip past any presumably has the same behavior?
No, skip past any will skip past as many.
As many as it can, okay.
It can.
Okay.
So the
Oh, and
that-
skip
and that's
past
why-
any and
that's-
try skip. Oh, okay.
Oh wait,
Okay.
so skip past doesn't skip other character. I thought it's like skip everything else and then skip delimiter and
No,
then
that's the greedy consume.
Yeah.
I don't know if there's a better name for that.
Okay, so skip past is, if I pass in comma, for instance, consume as many commas as you see until you see a non-comma character and then
Yep.
stop.
So
Okay.
it's
And it'll
skip
return.
next.
Okay.
And it returns the amount that
More
it actually
than-
skipped
Shouldn't we
past.
just, can we drop the skip? I mean, not skip, sorry, the past, and just call
Yeah.
it skip.
Yeah.
Skip
Well,
and skip any.
Because
Wait,
like I wanted to be very explicit that it didn't like skip 2, because I also have skip 2.
Yeah.
Skip 2 goes to it
Yeah.
and then stops. Skip past goes past everything that it sees.
Well, try
That's
skip
what
2
skip
should be like
means.
advanced 2.
Huh?
That's
Yeah,
what
it-
skip means.
you're right.
If I
Yeah.
say skip next 2 days, it skips next 2 days. You know.
Yeah,
Well,
so
but,
the, so
no,
the,
but if you want to skip to Friday,
Then yeah, I have
You
to
go
use
to
2.
Friday.
That's a common
So actually, so-
in human languages. Like
Yeah.
so
sometimes
so,
you need
so
to
you're
put-
saying skip and skip 2.
I like
Jeremy,
Josh's
the
proposal.
second, yeah, exactly. Well, I like it too. But like the try skip 2, why isn't that just advanced 2?
Why isn't it advanced 2?
Yeah, because I mean, you when you said, oh, I want to skip 2 next Friday, you want to advance to next Friday. You want to go to that thing without skipping it. So adding skip in there might
Try skip.
not be the best.
That's fair. I mean, just.
And if we get rid of it there, then maybe the first half of the APIs that Christoph was suggesting with the different
Well, and
names.
then we can call them all advanced. We can
Right.
call them
Oh.
advanced past and advanced.
When do,
Advanced past and advanced too, maybe.
when do you advance
that-
to?
that-
or just skip first.
That's fair.
When you advance to, when you want to
Well,
find an int,
right.
so you say advance to any digit.
So you're just skipping data left and right just to find it?
Well, maybe it's a white space, or like.
Yeah, but why are you skipping data? How many parsers
Well,
need
like-
to?
Well,
I want to
when you-
ignore all white space and get to the next token.
Yeah,
Yeah.
so,
And
but then
skip
you
past
ignore
these
all
white
white
spaces.
space. You don't
Yeah.
just.
Oh
don't
yeah, but
really
grab
but,
onto
know
but,
what
but
data.
it's skip. It's just skip white spaces. It's not skip to next something. In your example.
Yeah.
Well, he
Because-
would have a custom extension method at that point because it's a specialized search.
No, I'm saying I get skip next or
Yeah.
whatever we call
But he
it
doesn't-
skip
he
pass,
doesn't
but I
try
don't
skip
get skip two.
Yeah.
Because
Because
You
in
generally don't overread
'cause-
arbitrary characters just to find something that you know. Like that's.
Well, this is the case for the like because there's actually like multiple layers. The JSON reader is not the JSON parser, so he's actually just splitting up the data,
Right.
right? So he's reading a delimiter, and by the rules, you read from that delimiter to the next delimiter.
Okay, I'll give you a scenario.
Yes,
You're
please.
trying to skip past a comment in C#.
oh,
That is a good
you'd
example.
better
You're
not
writing-
use this method, or your parser would be
What?
not entirely correct.
Why? You want to skip till you hit
A C-style comment.
star
Okay, C-style
and,
comment.
and,
C-style.
and forward slash. Yeah, exactly.
Correct.
I don't know.
But then-
No, that is-
okay,
that's legit.
the point is taken. It probably is not as
Or
Like
an
I'm
Excel
asking, is
comment,
it
or-
too specific to something we wrote and we decided to make it into an instance
it's a
method
good question.
that-
It's not as common probably.
C, XML comments,
yeah, but you skip to what to ignore C-style comment?
You would do skip past in that
skip
case,
past, yeah.
not skip two.
No,
Yeah,
you
skip,
you
skip past a new line.
you
if
just
you're-
you have to search.
Oh, I'm sorry,
your
C-style.
line. Yeah.
You search until the asterisk and then see if it's followed by a slash.
It does happen. I mean, how often does it happen? Like, I think enough to have it, but like, it may not happen. You may use this 10% of the time, and the other one 90% of the time.
Good for all bugs.
I think it's enough that it's actually.
Give me before because I'm having a hard time keeping the notes because we changed our minds so much. So like, what are we doing with? So skip past. What did we say? We just keep
we
it as.
we want to do all the skips to advance.
Is that what we said?
So
Like all notes on
so we want advance and advance too.
Yeah, sure.
So skip past is
What about skip and advance too?
advance.
Keep skip.
Yeah,
Skip to advance
Yeah.
two.
You can't overload the advance method.
Yeah.
You have to call it advance 2 or something else.
Oh, you're right.
Yeah.
So
Because
advance-
otherwise, if I have read sequence of long, now I'm screwed.
So we do advance past with advance too.
Which one is advanced? Oh, the skip past.
Yeah. Advance past, advance two.
I guess so. We could
So
do
what
It
is
seems
it?
weird to keep one skip and make the other one advance, right? To me.
Skip and try skip to.
Sorry,
Yeah.
skip past is advance past, right? And then try skip to is.
Advance two.
Let's call them all advanced. They will be like group in IntelliSense, and they will be all advanced, and then you advance either by an index or by.
Would you
search.
find the real advance that you care about?
Yes.
Of int.
Because it's the one that's actually called advance and it has no overloads.
Okay. It has an. Alright.
No, it can't have overloads.
Right.
And the reason that it can't is once you have like sequence reader of long or sequence reader of any int,
Yeah.
now you're screwed.
Okay.
We could call it advanced by.
It's a radical.
No.
Everywhere.
Or we could just have a sequence.
Extension.
Advance count.
We have
Right.
extension.
Advance by count.
Or we could have find position and then advance that takes position.
So the
All of the cases are taken now.
the extension methods that you have here look like they're basically just UTF-8 parser dot stuff, right? The
With
signatures
very
match.
special caveats, which I
Yeah.
have a very long, detailed comment on the bottom.
Yeah.
Our UTF-8 parser is unbounded
Yes.
in that it will read any number of insignificant digits in a number of things that it reads. So you can have 2 gigabytes of zeros plus 123.
Yes. That is correct.
That's problematic from a parser that like goes across segments,
Why?
because you may read, like you think about denial of service, right?
Yeah.
You know, somebody feeds in something that they know is going to like hork you because you're going to allocate out the wazoo because you have to make it
Why?
contiguous.
Sorry. Why would you allocate?
Because we call the UTF-8 parser underneath.
No. So what? You would have to duplicate some of the logic.
Well, precisely. That's the other option, and then
Yeah.
you like
We don't want to duplicate the logic. This is the
You-
UTF-16
as much as
discussion. It's
possible.
enormous amount of code.
You
correct?
have to duplicate some of the logic.
No, we can
So
just
like
basically say we
so-
don't parse anything if you have more than 100 zeros in front.
So that
Skip it yourself. If you have 5 gigabytes of zeros, skip it yourself and then go parse.
and there's more to this. This is a very long and
No, I mean,
so
yeah,
I'll tell you what we did,
yeah,
and then we'll go into the reasons why. But
Yeah.
like what we did is we constrained all these things to only be valid if it was able to read it in less than 128 bytes or T's. Right. So
okay, sure.
and well, the presumption that that's easy to document and say like, okay, if you're out in this sort of outer world space where you're like, you have 1,000 digits that you're trying to read an int out of, then like you have to deal with that. That's a
Yeah,
known
but
limitation.
surely you're not like copying. Surely you're not making a buffer of 128 elements every single time and then
No.
calling UTF-8 parser.
No, the logic in there is pretty complicated that we do. So like
Yeah.
we say like as long like again there's the presumption that our sequences are typically going to be like 1K or bigger, right?
Yeah.
So usually you're going to have more than 128 bytes left, right, to look at. So
Yes.
the logic becomes very simple. We just ask it to parse.
Mhm.
If it said true, if it's 128 or larger, we just return false.
Yeah.
If we're across those boundaries, that's when we actually get into the place where we have to say like, okay, now we need to do a little bit more difficult logic. And depending on what it is, because the rules here are very different between
Yeah.
these things and the sort of issues that you run into, we either like iterate to like kind of grow it out because we expect it to be like just slightly over whatever was left or whatever, or we go straight to the 128 because in the case of something like the one interesting example is like you want to read out something in scientific notation, right? You don't know if you end on an E with whatever you pass as to whether or not like the next thing is going to help you out or not.
Right.
So we can't look at, we did hard code for the int case to say plus minus ending on a thing we'll try again, right? But like some arbitrary place looking for E and stuff like that, it started to get really complicated.
So let me ask this then. So say that the current span has 4 bytes remaining,
Mhm.
and so I call try parse int. Like, what do you do under the covers?
Well, we
Do you-
call
you
it,
grow
we,
the-
we call it,
You call what?
we call try parse
Yeah.
on the 4 bytes.
Yeah.
If it returns true in 3 bytes, we know that it consumed all the valid data it needed to. Like it hit something invalid, it's done,
Okay.
right? So we're good at that point. If it returns true and returns 4 bytes, well, we don't know what's
Then
next.
you
Then we
expand.
have to go down until we have to call until it returns either true and less than what we passed it, or potentially over 128 in the first pass because we gave it a
Okay, and if it returns false, then you expand and try again as well.
only in some cases.
Okay.
So in like Boolean, it's pretty simple and straightforward. We
Yeah.
just that's always the same sizes, so we have some optimizations there. In the case of int, the only weird case is if it started with a plus or minus.
And then stuff like GUID, like your special case.
GUID is special cased on its own because like GUID is only one of like
Yeah.
4 sizes.
But now this means that you're duplicating some of the logic from UTF-8 parser.
Very little.
Okay.
So it will. The only logic that we're duplicating is an optimization.
Okay.
Right. There's one that could potentially break. Right.
Okay.
Like if we added another format to int, like that took something other than a plus or minus at the beginning, then we'd have to go back and do it. But that's the only one we have.
Well, that means that whenever standard format is updated in UTF-8 parser, you might need to update this as well.
Hopefully never, right? So that was the only one where I took a bet that like it would be this is enough of a hard tie because like plus or minus.
Okay.
It's actually more. It's more aggressive than that.
Yeah.
It says if it's under this character, because we want to make the checks fast. I say
Yeah.
if there's only one character and it's under this character number, then I go to the next path. I could make that always if it's one character and stuff like that, and go through the rest of the thing.
Why do we need bytes consumed argument?
Huh?
On the extension methods, we have out int bytes consumed.
Because you're not advancing the reader, or are you?
Let's try read. Oh, try parse. But it's try read in.
Well, because we found that like keeping track of that yourself is expensive.
Of what?
Getting consumed and like doing the diff on your own.
But try
We are-
does not advance, correct?
It does if it's successful.
Then why do you need to keep track of anything?
Hmm?
Like it either reads and advances for you, or
Well,
it doesn't.
I want to know how many. Let's say I parse integer. I want to know how many digits it contains, so I can my internal buffer or state I can update.
You want to know how
Let
many
me know.
digits it contained?
Which internal
How many
buffer?
digits it consumed? So like
Wait, which
we-
internal buffer?
As a
is it?
consumer, I have a consumed count.
Why?
Bytes consumed?
No, just like, okay, so let's say you have integer.
Yeah.
I want to read it. It's like an arbitrary length.
Right.
Tell me the size of the integer that you read.
Like,
That's what
But you can calculate it from the existing properties on sequence reader.
So of course you can, but like we
No,
actually
just the operation. You did track parse.
Yeah.
You read an int. I didn't know what the int was. Tell me how long the int is.
right, but we just gave you the int.
Yeah.
Yeah, but
But
while you did it, why are you asking me to calculate the length of the int now?
But why
Because
do
you
we
can
need-
already get the
Well, it's not-
information yourself.
well that's when I added this specifically, the bytes consumed,
Yeah.
it was done as an optimization because getting the current count and then getting it again was just measuring.
So,
But why do you even need it? Like, in what
You
parsing
don't
scenario you
do
need
not
it?
need it. It's a convenience factor.
Yes,
that's
but
an
it's a
optimization.
convenience factor that all callers are paying for now, even if they don't need it.
so I would
Well,
differ-
it's always being constructed though,
so should we
because the underlying thing actually does it as well.
should we wrap this up because we are basically
Yeah.
Yeah, we do have to
we're
wrap it
done.
up, but we have probably a whole nother.
I think there's at least
Yeah.
another meeting on the extension methods
But,
because
yeah.
we're just
But this is though another example of what I mentioned earlier about I think we're changing the public API surface for like a performance optimization that either few people need or the widget can make better.
Yeah, and I'm I'm fine with arguing over this one and like
Yeah.
taking it away. It's just like it wasn't there to begin with. We added it because like it was measuring in the JSON reader scenario.
Yeah.
So yes, technically you absolutely do not need it. You can get the context from other things. It was
All right.
merely a convenience thing, a speed/convenience thing.
all right. Thanks, guys online.